start with the stark findings of an international team of scientists led by the UK Met Office, which raised profound questions about the future of the Earth's climate. The team says that a prolonged heatwave in the Siberian Arctic this year is unequivocal evidence of climate change, and that the record high temperatures in Siberia would be impossible without man-made global warming.
In the frozen heart of Siberia, a massive pit is slowly expanding, and it does not behave like a normal scar in the land. It grows year after year, pulling trees, soil, and entire layers of frozen ground into its widening mouth, as if the Earth itself is collapsing inward. For people living nearby, this is not a distant scientific curiosity, but a moving threat that never stops. At first glance, it looks like a rare geological accident, but scientists call it Batagaika, and what worries them is not its size alone, but what its growth reveals about a frozen world losing control. So what exactly opened this gateway, and why now? The Batagaika megaslump did not appear overnight, and its origin tells a quiet but unsettling story about how stable ground can suddenly fail. This vast crater lies in the Yana highlands of northeastern Siberia, a remote region shaped by extreme cold, deep forests, and frozen soil that once seemed permanent. For centuries, the land here remained locked in ice, protected by permafrost that acted like natural concrete beneath the surface. Nothing suggested that the slope would one day collapse into something so massive. The first crack in this frozen stability appeared in the 1970s, when part of a hillside began to give way. As trees were cleared and surface layers were disturbed, darker soil absorbed more heat from the sun. That small change mattered. The frozen ground below, which had remained sealed for hundreds of thousands of years, started to thaw. Once exposed, the ice-rich soil lost its strength, and gravity did the rest. The slope collapsed, pulling more frozen layers into the open and setting off a chain reaction that never truly stopped. For years, this process went largely unnoticed because the area was so isolated. It was not until 1991 that satellite images revealed a strange scar growing in the landscape. From above, the shape looked unnatural, like a widening wound carved into the hills. Scientists quickly realized this was not a typical landslide. The exposed ice layers were ancient, some of them frozen for roughly 650,000 years. When such old ground thaws, it does not simply settle. It melts, drains, and collapses, creating space for even more material to slide inward. What makes Batagaika especially troubling is the uncertainty around its true age and pace. Researchers cannot say exactly when the first collapse began, only that it likely started decades before it was seen from space. Since then, the crater has continued to grow, not downward into the Earth's core, but outward across the surface. This sideways expansion is what gives it power. Each year, its edges retreat farther, exposing fresh permafrost and feeding the process again. Measurements over recent decades show how serious this growth has become. The headwalls of the crater have been retreating by tens of feet per year in some sections, and millions of cubic feet of frozen soil and sediment are released annually. To make that easier to picture, scientists compare the lost volume to hundreds of Olympic swimming pools emptied every single year. These numbers shocked researchers because permafrost landscapes were once thought to change only over long geological timescales. Batagaika looks like a single disaster, but its origin reveals something larger. It shows how a small disturbance in frozen ground can awaken forces that were locked away long before humans existed. Once the process begins, there is no simple way to reverse it, because the crater creates the conditions for its own growth. The land collapses, more ice melts, and the cycle continues. If one exposed slope was enough to open this gateway in Siberia, how many other frozen hillsides are closer to the edge than we realize? For a long time, permafrost was seen as one of the most stable parts of the natural world, and Batagaika is now proving how wrong that belief was. Frozen ground in Siberia formed over thousands of years, locking soil, ice, and organic material into a solid mass that barely changed from one generation to the next. Scientists once believed this layer could resist short-term climate shifts because its thickness and cold temperatures acted as a powerful shield. That assumption is now breaking apart in real time. What makes Batagaika different from a normal landslide is the speed at which it is expanding. Once the permafrost was exposed, it began to thaw from the edges inward, and each warm season pushed the boundary farther back. Measurements taken over recent decades show sections of the crater growing by dozens of feet each year. In some areas, the retreat has reached nearly 50 feet annually, a rate that shocked researchers who expected changes to take centuries. Instead of slowing down, the process has remained active and uneven, with some zones collapsing faster than others. The amount of material being released is just as alarming as the speed. Every year, millions of cubic feet of frozen soil and sediment slide into the crater. To put that into perspective, scientists compare this loss to hundreds of Olympic swimming pools emptied year after year. This is not just dirt falling away. It includes ancient ice and carbon-rich material that had been locked underground since long before modern humans existed. Once released, it changes the structure of the land and feeds the collapse even more. Despite how dramatic it looks, Batagaika is not drilling downward into the center of the planet. Studies show that the melting has already reached solid bedrock, which stops the crater from becoming a deep vertical shaft. This fact offers some relief, but it does not remove the danger. The real threat comes from horizontal growth, as the edges continue to break and spread outward across the landscape. This sideways movement allows the crater to consume new ground each year, including forests and frozen slopes that once seemed untouched. Scientists were especially surprised because permafrost regions were thought to respond slowly to warming. Batagaika shows that once a tipping point is crossed, change can accelerate quickly. The exposed soil absorbs more heat, meltwater weakens nearby ice, and gravity pulls everything downslope. Each step supports the next, creating a self-sustaining cycle that does not need a sudden disaster to continue. It only needs time and seasonal warmth. What we are witnessing is not a rare anomaly, but a warning about frozen terrain under stress. Batagaika reveals how fragile these systems become once their surface protection is removed. If this much change can happen in a remote Siberian valley, it raises a troubling question. How many other permafrost regions are already unstable, waiting for a similar trigger to wake them up? Batagaika is not just growing larger, it is actively moving across the landscape, and that is what turns it from a strange formation into a living threat. Unlike a deep hole that stays in one place, this megaslump spreads outward year by year, breaking apart the frozen ground around it. The edges collapse, retreat, and pull new sections of land into the crater, which makes its path unpredictable. What once looked like a static scar has become a slow but unstoppable force. This horizontal movement allows Batagaika to swallow entire valleys. As the ground weakens, slopes that once held firm begin to slide, carrying trees, soil, and roots with them. Forests that took decades to grow can disappear in a single season. From above, satellite images show the crater stretching toward nearby lowlands, carving a wider channel through the terrain. Each collapse exposes fresh permafrost, and that newly exposed ice feeds the next stage of expansion. One of the most serious risks comes from water. Batagaika lies close to natural drainage paths, and its advance threatens to change the course of nearby rivers. When a river is forced to bend or break around unstable ground, erosion increases rapidly. Faster water cuts deeper into the soil, which weakens the surrounding land even more. This chain reaction does not stop at the crater's edge. It spreads outward, reshaping the entire local system. For wildlife, the changes are immediate and harsh. Animals that rely on stable forest floors lose nesting areas and feeding grounds as the land collapses beneath them. Birds lose trees, mammals lose shelter, and migration paths are disrupted. Even aquatic life can be affected when sediment pours into streams, clouding the water and reducing oxygen levels. These effects may seem small at first, but together they create long-term stress on ecosystems that evolved under very different conditions. What makes Batagaika especially alarming is that it is not alone. Scientists studying the region point out that similar processes are happening across parts of Siberia and the Arctic. Once permafrost begins to fail, the same pattern can repeat elsewhere. A slope collapses, ice melts, water flows, and the land follows. Batagaika is simply the largest and most visible example of a process that may be far more widespread. This realization changes how researchers view the crater. Instead of treating it as a single geological curiosity, they now see it as a signal. It shows what can happen when frozen landscapes lose their balance. The danger is not that the Earth will suddenly open beneath our feet, but that large areas can slowly become unstable without dramatic warning signs. Batagaika's steady march across the land forces scientists to look beyond Siberia. If frozen ground can move and reshape entire regions here, where else might the land already be shifting in ways we have not noticed yet? Batagaika feels shocking because of its size, but it becomes truly unsettling when scientists realize it fits into a much larger pattern across the Arctic. Over the past decade, researchers have documented a series of strange craters appearing in frozen regions, many of them forming suddenly and without warning. These holes did not grow slowly like Batagaika. Instead, they burst open, leaving deep circular scars in the ground that raised immediate concern and confusion. The first of these mysterious craters was discovered in 2014 when a helicopter pilot spotted a massive hole in the Arctic tundra. It measured more than 100 feet deep and appeared in an area that had looked stable only months earlier. As scientists rushed to investigate, more craters began to appear nearby. Within 10 years, several similar holes were identified across the region, all sharing the same sudden and violent origin. At first, explanations ranged from dramatic to extreme. Some suggested meteor impacts, while others even floated ideas involving unknown technology. These theories faded once field studies revealed unusually high levels of methane gas around the craters. The Arctic permafrost contains large amounts of this gas, trapped beneath layers of frozen soil and ice. Over time, methane can build pressure underground, especially as warming temperatures weaken the frozen seal above it. The real mechanism behind these explosions turned out to be both simple and alarming. Deep beneath the surface, pockets of unfrozen salty water exist within the permafrost. As surrounding ice begins to melt, water flows into these pockets and increases pressure. When the stress becomes too strong, cracks form and spread upward. Eventually, the solid methane layer breaks, releasing gas in a powerful physical blast that tears open the ground. No fire is involved, which explains why there are no burn marks or signs of heat. What connects these explosive craters to Batagaika is not their shape, but their cause. Both reveal how frozen ground reacts once its balance is disturbed. In one case, the land collapses slowly and spreads outward. In the other, pressure builds silently until the surface gives way all at once. Different outcomes, same warning. Permafrost is no longer a stable foundation, but a system under stress. The most disturbing part is how difficult these events are to predict. Unlike earthquakes or volcanoes, there are few clear signals before the ground fails. Methane can accumulate unseen, and ice can weaken below the surface without obvious signs above. This makes it nearly impossible to map where the next crater might appear. While most have formed in remote areas, scientists cannot rule out similar events closer to infrastructure or communities. Batagaika now looks less like an isolated disaster and more like a preview. It shows one path frozen land can take when warming continues. The Arctic explosion craters show another. Together they point to a future where the ground itself becomes unpredictable. The question is no longer whether these processes exist, but how many more forms they might take. If the Arctic is revealing new failures every few years, what other patterns are still hidden beneath the ice, waiting for the right moment to surface? Batagaika is not only destroying land, it is uncovering a hidden archive that has been sealed beneath the ice for tens of thousands of years. As the megaslump expands, it peels back layers of frozen ground that were locked away long before human history began. Scientists often describe it as a natural time machine, because each new collapse reveals another chapter of Earth's deep past. Unlike controlled excavations, this process is fast, chaotic, and impossible to pause. Inside the exposed walls, researchers have found ancient sediments, plant remains, and traces of animals that lived during the Ice Age. Pollen grains, roots, and fragments of long-vanished ecosystems appear as the ice melts. In some cases, DNA from prehistoric plants and animals is preserved so well that scientists can identify species that disappeared tens of thousands of years ago. These discoveries help reconstruct what the Arctic looked like when the climate was warmer and forests covered areas that are frozen today. One of the most striking finds came in 2018 when a perfectly preserved Ice Age animal emerged from the permafrost. Its tissues were so intact that fur, skin, and internal structures remained visible. Discoveries like this are extremely rare, but they show what else may still be hidden underground. Batagaika offers scientists a chance to study ancient life without drilling, simply because the land is collapsing on its own. The scientific value of these finds is enormous. They allow researchers to test theories about past climates, migration patterns, and how ecosystems responded to warming long before modern industry existed. By comparing ancient DNA with modern species, scientists can track how life adapted to earlier climate shifts. This information helps improve models used to predict future changes. However, this sudden access to the past comes with serious risks. When ancient organic material is exposed, it does not remain frozen forever. As it thaws, it begins to decay, releasing carbon dioxide and methane into the atmosphere. These gases trap heat and contribute to further warming, which feeds back into the cycle that caused the collapse in the first place. The more the ice reveals, the faster the process can accelerate. There is also concern about what else might be released. Bacteria and viruses that have been dormant for thousands of years can survive in frozen conditions. While most are harmless, scientists cannot be certain how ancient microbes will behave in modern ecosystems. The risk is not immediate panic, but long-term uncertainty, especially as larger areas of permafrost become exposed. Batagaika forces us to confront a difficult reality. Melting ice does not only erase landscapes, it unlocks stored material that can reshape the future. What once felt like a scientific opportunity now carries consequences that extend far beyond research. If the ice is already giving up secrets from the distant past, what will happen when even deeper layers begin to thaw? Greenland offers one of the clearest warnings of what happens when ice that seems permanent quietly disappears. For decades, scientists believed Greenland's massive ice sheet had remained frozen for millions of years, changing only at the edges. That assumption began to crack with a discovery that came not from a new expedition, but from a forgotten sample sitting in a freezer. In 1993, ice cores were drilled from deep within Greenland and stored for later study. Then they were left untouched for nearly 30 years. When researchers finally re-examined those samples, they expected routine measurements. Instead, they found something that should not have been there. Inside the ice were preserved remains of ancient plants and insects, including moss, willow fragments, and even a delicate Arctic flower. These were not blown in by wind or carried from the coast. They could only grow in soil exposed to sunlight. That meant one thing. At some point in the past, central Greenland was not buried under ice. It was alive. Further analysis showed that this transformation happened less than 1 million years ago. In geological terms, that is very recent. Greenland's ice sheet had fully melted, allowing a complete ecosystem to exist where kilometers of ice stand today. This discovery shocked scientists because it proved the ice sheet is not as stable as once believed. It can disappear entirely under the right conditions, and it has already done so before. The implications of this finding reach far beyond Greenland. If the ice melted once, it can melt again. A full collapse would raise global sea levels by several meters, enough to flood coastal cities and reshape shorelines worldwide. Millions of people would be forced to move, and entire regions would face economic and environmental disruption. What feels distant and theoretical suddenly becomes personal. Greenland's past also connects directly to what is happening in Siberia. Both regions show how ice reacts when warming crosses a critical threshold. In Siberia, frozen ground collapses and spreads across the land. In Greenland, thick ice sheets vanish and reveal a buried world. The processes look different, but the message is the same. Ice does not fail slowly forever. At some point, it gives way. Another concern lies beneath the surface. When ice retreats, it does not only release water, it exposes soil, organic matter, and microbes that have been sealed for thousands of years. In Greenland, melting ice could release ancient bacteria and viruses into modern environments. While most would likely be harmless, scientists cannot fully predict how they might interact with today's ecosystems or climate. Greenland forces scientists to rethink timelines. What once seemed like changes spread across many millennia can happen within a much shorter span. The ice does not need millions of years to respond. It only needs sustained pressure. This realization shifts how researchers view Arctic stability as a whole. Batagaika shows frozen land collapsing from below. Greenland shows ice vanishing from above. Together they form a warning that is impossible to ignore. If these massive systems have failed before and are failing again, the question becomes unavoidable. Are we watching the early stages of a cycle that history has already written, seen once before? The melting ice does not only reshape the land and reveal ancient bones, it also releases life forms that humanity has never faced before. Deep inside Arctic ice, scientists have discovered giant viruses and ancient microbes that survived in frozen darkness for thousands of years. These organisms are invisible to the eye, yet their presence adds a new layer of uncertainty to an already unstable world. The danger is not dramatic or immediate, but quiet and deeply unsettling. In 2019, researchers studying dark ice and reddish snow in Greenland made a surprising discovery. They were trying to understand why some ice surfaces absorbed more sunlight, which speeds up melting. Inside those samples, they found a giant virus unlike anything most people imagine when they hear the word virus. This organism was 100 to 200 times larger than typical viruses and could be seen under a regular microscope. It did not attack humans or animals. Instead, it infected algae living on the ice. This behavior creates a strange balance. When the virus infects algae, it darkens the ice surface. Darker ice reflects less sunlight, which can slow melting in some areas. In this way, the virus may act like a natural shield, slightly protecting the ice it lives on. At the same time, its existence proves that complex biological systems have been frozen and preserved far longer than expected. If one giant virus survived, others may still be trapped below. Scientists are cautious about what this means. Most ancient microbes are likely harmless, but the problem is uncertainty. Modern ecosystems have never interacted with organisms that evolved under Ice Age conditions. Once released, even simple microbes can behave in unexpected ways. They may interact with plants, animals, or other bacteria differently than anything we have seen before. The risk is not a sudden outbreak, but slow and unpredictable change. This concern extends beyond Greenland. As permafrost melts across Siberia and the Arctic, similar biological material is being exposed. Batagaika shows how quickly large areas of frozen ground can open. Each collapse releases soil, organic matter, and microscopic life that has been sealed away since before recorded history. The deeper the ice melts, the more unknown material enters the modern world. Scientists also worry about scale. A single discovery is manageable. Widespread release is not. As warming continues, larger regions of ice will thaw at the same time. This increases the chances that ancient microbes could spread through water, soil, and air. While there is no evidence of an immediate threat to human health, researchers stress that preparation matters more than panic. The invisible threat is not about fear, but about awareness. Ice has always acted as a natural barrier, locking away not just landscapes, but entire biological chapters of Earth's history. As that barrier weakens, humanity is stepping into contact with a past that was never meant to return all at once. If melting ice is already releasing organisms we barely understand, what else might emerge as the frozen world continues to open? From collapsing ground to ancient life resurfacing, the Arctic is revealing how quickly balance can be lost. What happens there does not stay there, because ice connects the planet in ways we often ignore. This is no longer a distant warning, but an early message written into the land itself. If one frozen slope can consume a mountainside, what else might already be shifting beneath the ice right now? Share your thoughts below, and follow Mindgap to keep exploring what the Earth is slowly uncovering.